A falling object accelerates at a constant rate due to the force of gravity. As the object falls, the velocity will increase at a constant rate. The free fall acceleration due to gravity, symbolized by the letter g, is 9.81 meters per second squared at the Earth's surface. If only the force of gravity is acting on the object, then the motion is known as free fall. Air resistance is a force that slows a falling object. That is why a falling object can only be in free fall if it is in a vacuum. If an object, like a spacecraft, is in free fall, the occupants inside will also be in free fall and appear to float. In the 16th century, Galileo theorized that if there were no air resistance, all objects would fall with the same acceleration. Let's drop two objects into a room that has had all the air removed. A camera and a strobe light reveal that the two objects move together at all times. Notice also that the two objects move a greater distance during each time interval. The distance between two successive images is proportional to their velocity during that interval. So you can see here that the downwards velocity is constantly increasing. In a full second of fall, the velocity will increase by 9.81 meters per second. The acceleration caused by gravity near the surface of Earth is therefore 9.81 meters per second per second. Let's toss a ball into the air and think about its velocity and acceleration as it travels. When the ball is first tossed into the air, it is moving quickly upwards. It slows, then changes directions, and speeds up again on the way down. Let's look at this again and focus on the velocity. Suppose the initial upwards velocity is 20 meters per second. As the ball travels upwards, the velocity slows. Let's freeze the motion at the top. At this point, the ball is no longer traveling upwards, so it does not have a positive velocity. However, it has not yet started moving downwards, so it cannot have a negative velocity either. The ball must therefore have a velocity of 0. Next, the ball starts to descend and gains speed as it travels. Let's throw the ball one more time and graph its velocity as a function of time. As you can see, the velocity changes smoothly from upwards, positive, to downwards, negative. Remember that acceleration is the slope of the graph of velocity versus time. You can see that the velocity graph has a constant negative slope. This slope is the acceleration due to gravity, negative 9.8 meters per second squared. The ball has this same acceleration at all times, even as its velocity is positive, then briefly 0, then negative.